Hi, this is video 2.6a, Introduction to Related Rates. This is an application of derivatives, one of many. And after this, we'll be done with chapter 2 and into chapter 3, which is further applications of derivatives. Okay, so what are related rates? The first type, first of all, it's an application of derivatives, and there will be two rates. You'll be given one rate and asked to find another. The first few will be algebraic. There won't be any word problems associated with it. They'll just give you a rate. You'll be given one rate of change. For now, you'll be given an equation that relates two variables, and you'll be asked to find another rate of change. So here's an example. If you look at the book, wrong book. If you look at these examples right here, assume that x and y are both differentiable functions of t, and then find the required values of dy dt and dx dt. First of all, I find that they give this all backwards. First, they should tell you what the given rate is. Then they should ask you which rate you want to find, they want you to find. And then they should give you the equation that relates those two variables. Now you'll notice in every one of these, they either give you dx dt and ask you to find dy dt, or they give you dy dt and ask you to find dx dt. The two variables in the numerator are x and y, and you'll notice in each case the equation they give you is in x and y, the two variables that are in the numerators of these two rates, the one you're given and the one you're asked to find. So, for example, number 2a, they give you the rate dx dt equals 2. They ask you to find the rate dy dt when x equals 3, and they give you the equation that relates the x and the y, which in this case happens to be this equation. So, if you're going to find dy dt, obviously you're going to need to take d dt of y. So we're going to take d dt of each side. Remember, we're in t-land, so this is why it's important that you know implicit differentiation. So the derivative with respect to t of 1y is 1 dy dt. Here we get 4x dx dt minus 6 dx dt. Now remember, at this point you can start plugging in values. They told you dx dt is always 2, and they asked you to find dy dt when x is 3. So you replace the 2 dx dt's by 2, you replace the x by 3, you simplify, you have your answer, dy dt is 12. The key thing is that the first thing you're going to do is take d dt of each side, and then you're going to substitute in the values. Do not do that in the reverse order. Here's another example, number 4b. This time they give you dy dt equals negative 2. They ask you to find dx dt when x equals 4 and y equals 3. They're being kind. Later on, they won't give you the when y equals 3. They will simply say when x equals 4, it'll be up to you to plug x equals 4 into the equation, which in this case they're giving you in order to find out that y happens to be 3 when x happens to be 4. And of course, for now, they're giving you the equation that relates the x and the y. In this case, x squared plus y squared is 25. So remember, the order we do this in is first we take d dt of each side, and then we're going to plug in these three values. So we take d dt of each side, we get 2x dx dt plus 2y dy dt equals 0. Now we substitute in the values. They said to find dx dt when x equals 4 and y equals 3, and they gave us dy dt as negative 2. The only missing quantity is the one we're looking for, which we find and simplify. It's not that hard. Okay, numbers 5 through 8 are little baby word problems. Okay, they're going to build up to just random application problems. Right now, 5 through 8, a point is moving along the graph of the given function, such that dx dt equals 2 centimeters per second, which means with the passage of each second, the x value is 2 more than it used to be, which means the point is moving to the right at 2 centimeters per second. The question is, how fast is it moving up or down, depending on whether the function is increasing or decreasing? How fast is the y changing for the given value of x? Okay? So you're given the rate dx dt, you're asked to find the rate dy dt, and yet again, they're giving you the equation that relates the x and the y. Okay, so here we go. Let's take number 6c. So you're given dx dt is 2 centimeters per second. You're asked to find dy dt, and you're asked to do it when x equals 2. Notice I use the bar for when x equals 2. So what we're going to do, and they give you the equation. Now, there's various ways you could deal with this. You could rewrite y as y equals 1 plus x squared to the negative 1, and then do a chain rule with that. I left it as a quotient, so I'm taking d dt of each side of the given equation. I did a quotient rule, and then I'm substituting. I simplified a little bit, and then I substituted, because they told us dx dt was 2, and they said to find dy dt when x equals 2, so I replaced the 2 x's by 2. And I end up with negative 8 over 25, which means the y's are decreasing, so it's actually, as it moves from left to right, although it's moving to the right at 2 centimeters per second, it's moving down at negative 8/25 centimeters per second. You could look at this as 8 centimeters per 25 seconds, or 8/25 of a centimeter per second. But you will need to include units of measure, because you've been given units of measure. Okay, so this is just a review again. You're going to be given a rate. Somehow, in the words of the problem, you're going to have to decide if that variable, that quantity, is increasing or decreasing, so that you'll decide whether to put a plus or minus in front of that number that they give you, and they will give you these units of measure. Write them down. They're then going to ask you to find another rate, d something, usually dt, and usually when a particular variable equals a number. It's going to be up to you now to find the equation that relates the two variables in these two numerator positions. After you've done that, you're going to take d dt of each side and then plug in the given numbers. And we'll be looking at that at the next video. This is the end of video 2.6a.